Good afternoon, children. Are you all tired after the morning classes? Anyways, let's study a little bit of mathematics today. What did we study in the previous class? What are the concepts that we've learned? Yes, we learned two concepts. The first concept is that as the number of polygons that is inscribed in the circle increases, it becomes closer and closer to the circle. And the second concept that we saw was, if the diameter or radius of a circle is given, then we can find the perimeter of the polygon that is inscribed in the circle. These are the two concepts that we learned in the previous class. Hope you are thorough with it. Now, today we shall learn a new concept. Before that, let me ask you, what all festivals do we celebrate in our school? And for what all do we get holidays? Yes, we do celebrate Onam, Christmas, yes, Puja, Diwali, Eid, etc. Yeah, and goes on. So, how do we celebrate Onam? What are the activities that we conduct for the Onam celebration? Yes, we will put Pookalam, Tiruvathirukali. Yes, there will be Sadhya with a variety of payasams. Yes, there will be tug of war. And for the competition Pookalam, we will prepare a design of the Pookalam beforehand. Now, teacher shall show you a simple picture of a Pookalam. Now here, take this point, let us name this point as O. Now, taking this point O as a center, let's draw a circle around this. Now, we shall draw an equilateral triangle inside this circle. Now, join the point O with the vertices of the triangle. Let's name the vertices of this triangle as A, B, C. Okay, now we have a circle and a triangle drawn inside it. Now, taking this point O as a center, draw a bigger circle around this circle. Now, we shall extend the lines that join the point O with the vertices. Here, we have extended the lines that joins the center O with the vertices of the equilateral triangle ABC such that it touches the point on the bigger circle. Now, we shall join these points. we shall name this triangle as PQR. So what we have got here? We have got here a point O as a center and a small circle around this. We have an equilateral triangle ABC inscribed in the small circle. Now, taking this center taking this point O as a center, we have drawn a bigger circle and we have inscribed an equilateral triangle PQR. Now, what have we got? We have got a picture like this, right? So here, do you find any relation between these triangles ABC and PQR? Do you find any relation between these two triangles? The triangle ABC and the triangles PQR both are equilateral triangles. Just say whether you can find any relation between these two triangles ABC and PQR. Yes, in the triangle ABC and PQR, all the sides of the triangle are same. That is one relation. Now consider the triangle AOB and POQ. Do you find any relation between these two triangles? What? Yeah. The side of the triangle AOB, that is the sides AO and OB, they are same. That is AO equal to OB. Why we can say so? Because the sides AO and OB are the radius of the smaller circle. Now, what about the triangle POQ? The side PO of the triangle POQ is equal to the side OQ because they are the radius of the bigger circle. So we can say that in triangle AOB, the side around AO is equal to OB. And in the triangle POQ, the sides OP is equal to OQ. Okay. Now, from this we can say that AO by OP, this is equal to what? OB by OQ. Right? Run these two. We can write AO by OP equal to OB by OQ. This can be written in the ratio concept as AO is to OP. The ratio between AO and OP is equal to ratio between what? The ratio between OP and OQ. Right? So what will we see here? Here we saw that as the sides OA and OB, triangle AOP increased. Then the side AB also increased. And as the side OP and OQ also increased, the side PQ also increased in the same ratio. This happened when we consider triangles what? AOP and POQ. Now we shall consider the next triangles, that is BOC and QOR. In these two triangles also, it says that as the two sides of the triangle are scaled by the same factor and the angle between them are the same, then the third side also is scaled by the same factor. That is, when the side OB and OC increases or decreases, and the side OQ and OR also increases or decreases in the same factor, and the angle between them, that is the angle BOC and QOR, they are the same angle, right? Since the angles are also same, then the third side, that is BC and QR, also increases in the same factor. This can be applied to the triangles AOC and POR. Now what we see that here, we can see that the sides OA, OB and OC, these are increased, that is the radius are increased. And so what happens, as the radius increases, the sides of the triangle also increased, that is their perimeter increases, right? When the measure of the sides increases, their perimeter is also increased. The measure of the sides are the radius over here. So as the radius increases, the perimeter increases. We can say that what radius is half times the diameter, right? So we can say that as the diameter increases or decreases, what happens? The perimeter also increases. Now here we have another figure. Here we have the figures, a circle, there are two circles and there are two regular pentagons. What are the pentagons that we have? We have a pentagon ABCDE and the pentagon PQRST. Here we drew these two regular pentagons and circles. Before we draw the triangles, right? And similarly, we draw this figure also. How did we do it? We first took the point O as a center and drew a circle. Then we drew a regular pentagon inside the circle. And we joined the point O, that is center, to the vertices of this pentagon. And then we extended the lines that join the center with the vertices of the regular pentagon so that it touches the points on the circle. Then we join the points on the bigger circle to get a bigger regular pentagon. That is how we drew this figure. Now, compare this figure with the triangle that we learned just before. What can we see? Here also, we can see that the regular pentagons are divided into different triangles. Consider the triangle AOB and PQO. What can we see here? We can see that in the triangle AOB and POQ, the side AO is equal to the side OB. Why? Because these are the radius of the smaller circle. Now consider the triangle POQ. We can see that the side OP is equal to the side OQ because they are the radius of the bigger circle. Right? So we can write in triangle AOB. The side AO is equal to OB. AO is equal to OB. And the triangle POQ, the side OP is equal to OQ. Why? Because they are the radii. Now we can write this within the ratio form, right? So that we can write it as AO by OP is equal to what? OB and OQ. OB by OQ. Now let us write in the ratio form. AO is to OP. This will be equal to what? OB is to OQ. Right? Now we have learned the fact in the similarity of the triangles, right? What we did learn? We learned that if the sides of the two triangles are scaled in the same factor and the angle between them are the same, then the third side will also be scaled in the same factor. Which are the two sides that are scaled in the same factor? The two sides that are scaled in the same factor of the triangles AOB and POQ are the sides AO, OB and OP and OQ. And which is the angle that they have in common, that is the angle O, which show AOB and POQ. So this is the angle that they have in common. So the third side, that is AB and OPQ, they will also be scaled in the same factor. That is, if these sides increases, then the third side will also increase in the same factor. That is, if the radii increases, the third side will increase. If the radii increases, if the sides increase, what will happen? The perimeter increases. So if the radii increases, what will happen? The perimeter increases. Radii is half that of the diameter. So we can say that if the diameter increases, the perimeter increases. That is, the diameter and perimeter, they are scaled in the same factor.
Here you can see a video that if we take any polygon, we can divide it into triangles as we did to see that the ratio of the perimeters is same as the ratio of the diameters. Here we are given two circles and the ratio between the diameters of these two circles is given. Also the ratio between the perimeters of the polygon inscribed in it is also given. We can see that as the diameter keep changing, the ratio between the diameters also keep changing. Also, the ratio between the perimeters of the polygon also keep changing. This is applicable to any polygons, whatever be the number of sides.
Hope you understood the concept. So now I shall give you a homework. You just write whether you can work it out. Okay. So the homework is, you draw a square in the same way. That is, there will be two circles and two squares will be inscribed in it. You draw it in the same way as you drew the regular pentagon and equilateral triangle, and just write which sides are equal and the ratio between those sides, and write the fact that you understood below it. Okay, this is just a simple homework, just write out. So thank you and see you in the